Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn more about Pandas. In the previous video we looked at how to create custom bounds for windows using the base indexer methodology. In this video we'll look at how to calculate correlation and covariances for a rolling window. I've already gone ahead and created a new Jupyter notebook and imported two libraries, NumPy and Pandas. And for data, I've created this DataFrame which has three columns A, B and C, and they have the index which is date time indexes. Now for a rolling window which has correlation covariances, the method is very simple. Let's look at that now. Rolling covariance and correlation. If we type df, so let's look at our data frame first. So this is how the data frame looks. Here we have these numbers. I've purposely made them in specific order. So 1 through 6 increasing, and then 6 through 1 decreasing, and then we have just 2 which is constant. And in this case we have B which is increasing from 1 to 6, increasing again, and then increasing again from 1 to 6. And then for C we just have 0 and 9 repeating through the entire column. So here if we look at df.rolling, window is equal to 6, and therefore we are using the window size of 6 because we have these rows which are 6 rows right here. So A should be perfectly correlated with B because they are increasing with the exact same numbers, and there may or may not be some correlation within C. So that's why the window 6. Now here if you type COV, that will calculate the covariance, as we can see here, and this is the covariance between A and A. So because the first column is A, then A and B, and then A and C. And to check if this is what is actually happening, so if that is correct, what we can do is we can run the covariance calculation separately as well. So let's do that now. df.alloc, and we'll pick only those rows. So we know that only 0 to 6, those are the rows that we really care about. So we run that, and here we can see the output is 3.5, 3.5, 2.7, 3.5, 3.5, 2.7. This repeats, and the last row is 2.7 2 times and 24.3, and that's exactly what we have. So this is how we could calculate the rolling covariance, and the input data for this is all the rows from 0 through 6, so that entire window, and we get a nice matrix for each date that we are trying to get the covariance up to. Now similar to covariance, we can also calculate correlation using the same code, just changing the last word to corr, and that gives us the correlation. And here, as expected, we do see a correlation of 1 between A and B because those numbers increase in exact same way, and the correlation between A and C is not much because it's more or less random in as a random arrangement of A as compared to C. Now moving on, let's see what more methods or variations we can do with rolling windows for covariance and correlation. One of them is df.rolling, again window is equal to 6. Now here we can specify if we want to find the correlation with respect to any specific column that exists in the data frame. So in the data frame that we currently have, three columns we have right here, A, B and C. So if we want to explicitly specify that the correlation needs to be with reference to the column B, we can do that. So to do that, we would specify corr, then df, and within parentheses we want to specify df of B. And when we run this, we now have the correlation in columns A and C, which is with respect to column B. So this correlation 1 is between A and B, and this correlation 0.29277 is with respect to B as well. And the correlation for B itself with B is going to be 1, and therefore all the values here are 1. Now, what if we want to calculate covariance or correlation between groups of column within the same data frame? So let's say we want to find the correlation between A and B here and B and C. How do we do that? Or if there are different other columns, maybe A, B, C, and there is some other column G, H, and maybe K somewhere. How do we do that? So to do that, we can type df of AB. I'm putting an X there just to store the output in that variable, because we can go ahead and plot that. df, we are taking two columns from the data frame AB, and then use them with the rolling function with a window of 6 to find the covariance with another set from the same data frame B and C in this case. And here if we run this like this, we get a covariance output right here, but it does not make much sense. So what we need to specify here is pairwise is equal to true, and now we get a nice matrix like we see here, where we have covariance between, this is between the column B and the column A, and here we have the covariance between column C and column A. And again, this is the variance for column B and the variance, and this is the covariance between the column B and C. Now if we want to check if that's the covariance, that's the variance for column B, we can go ahead and do that. So this is the very first set of B. So what we can do is type np.co, we just need the variance, so np.var, and here we can specify df, and we just need the column B, so we'll specify the column B, and .iloc, this is just 0 through 6, that's all we care about, and in the output we get 2.916, and if we scroll up here we have 3.5, and that's because for this 3.5 below we haven't specified DDOF is equal to 1, and that's to get the unbiased version of the variance, and here we now get 3.5. Similarly, if we want to check the covariance as well, we can do that. So df, and here we just look at the columns A and B and .iloc, and we'll just take the 6 records from there and look at the covariance, and this is 3.5, and if we scroll up, that's what we have between A and B, which is 3.5. If you are not familiar with correlation and covariance, I'll highly recommend that you go back and check the videos in descriptive statistics in this series. There we discuss covariance and correlation in much detail, as well as correlation. Moving on, now let's look at how we can use the values within this particular variable x. So we have this data. If we unstack this, so for plotting, let's say what if we are interested only in the values where we want to find the correlation between the columns A and B for all the dates. How do we do that? So to do that, what we are going to do is use unstack. So x dot unstack, and here if we unstack using the level 1, which would be this level inside here, unstack 1, then we get this output. So what has happened here is the level 1 in indices which are right here. So this is a multi-index, this is level 0, level 1. We have pulled the level 1 in indices and put them right here in the columns. So A column now has both B and C, which are from here, and column B also has B and C, which are from here. Now to access the values for A, column A, and which is the level 0 index and level 1 index, we can do that by typing x dot unstack level 1, and then here in square brackets within parentheses and type A and B to get just the values of covariance between the columns A and B. So if you look here, we have for the date 0606 we have 3.5, then 7 we have 1, and if you go back to this data frame we have 3.5 for 06, and then we have 1, then 0.100, 0.100, and so on. So that's how we can pull the information using this unstack command, and then we can go ahead and plot this. So for this we need the matplotlib, so let's go ahead and import that matplotlib.pyplot as plt, and then here if you type plot, this should automatically go ahead and create the plot. So here what we can do is specify plt.show, and now we can see that the plot for the covariance between the column A and column B is also plotted. Moving on, let's see how we can find the covariances between two different data frames. So we'll create a new data frame df2, which is a copy of df, and just to make it different, I'm going to exponentiate it to 2, and that's what we have here. Now we can also go ahead and change the names of the columns just so that we can identify them. I'm going to capitalize the names and like so, and next if we type df.rolling, and here window is equal to 6 dot covariance, so cov df2 pairwise is equal to true, and now we get sorry, this has to be df2 column, this has to be columns. Okay, so now we have a nice output where A, B, and C, we have these up here, and then we have the second level 1 index for rows, which is capital A, B, and C, and right here we have the covariance values for the columns between two data frames. That was it for this video. I hope in this video you learned how to calculate rolling covariance and rolling correlation and use them in a data set that has indexes that are time series. This type of rolling calculations are widely used in stocks. If you are trying to analyze the stocks and finding trends in it, then this type of calculations are useful. I hope to see you all in the next video. Please like, share, and subscribe. Thank you.